This is going to be a continuation of the notes on parabolas. Last time we focused on me giving you an equation and you being able to identify the components like the vertex and the focus. This time we'll be going the other way around. Maybe I give you the directrix and the focus and you have to figure out what the equation should look like. This information should have already been copied down into your notes, but just as a reminder, one of the most important things you'll have to do in the beginning is figure out whether your parabola is opening up and down or left and right. So some things to notice are when they're giving you 2 points, like the vertex and the focus. If you can see that they're on top of each other, then it must be an x squared equation. If you see that they are to the left and to the right of each other, if it's the x coordinates that's changing between them, then you know that you have to have a y squared equation. For the directrix, just pay attention to whether it's a y equals equation or an x equals equation. That'll define the horizontal or vertical line, and that'll also indicate whether you have the x squared or y squared form of a parabola. These should also already be in your notes, but we will be referring back to them, so make sure you have them handy. And just like we were talking about from looking at it graphically, you can see that when the y coordinate changes, that's your x squared equation. When your x coordinate is what's changing, that's when you have a y squared equation. Also, don't forget that once we figure out what that value p is, we'll need to multiply it by 4 most of the time to get the actual standard equation, unless they've given you the focal width, which already has the 4 times p value given. So here's our first example. They're asking us to find the standard form for a parabola that has a vertex of 3, 4. So the first thing I like to do on these is indicate that that means I have the number h equals 3 and k equals 4. And now notice that when they've given us the vertex and the focus, it's the x coordinate that appears to be changing. So if we look at our equations, the x coordinate changes in this case, the right-hand column of formulas. So it goes from the h value to h plus p. So I know I have a y squared equation. I'm also going to mark that my focus value must be h plus p. And the k value stayed the same, it's still 4. So start off by labeling what information you have available to you and identifying which set of equations you should be using. By performing a substitution here, since I know that h is equal to 3, then I can plug that in to write 3 plus p equals 5, which means p equals 2. Now remember, most of the time we're actually going to be using the value 4p, so that number will be 8. So we should have everything we need to write our equation. Again, just make sure that you're using the correct form. We're going to use the y minus k squared equals 4p x minus h. So now we have y minus k squared equals 4p x minus h. So now we have our set equation. All we needed was that h, k, and p value. And in general, that's what you'll be doing on these. It's just figuring out from the beginning which type of equations do you have. So here's another example. Now this time we have that the h value is equal to 0 and the k value is equal to 0, which usually makes things easier, but sometimes people forget then it makes the equation look very different since you don't have numbers being added and subtracted inside of the parentheses. So we definitely want to take a look at one. Also, for our directrix, we have y equals -3. So if we look back at our equations, there's the directrix that has y equals a number, and there's the directrix equation that has x equals a number. So right now, I know that it's got to be the x squared version, and I'm going to be writing y equals k minus p. So -3 equals k minus p. Now since we know that k is equal to 0, that means -3 equals 0 minus p. So if you multiply both sides by -1 and multiply it by 4 to get 4p, now we have our h, k, and p values. So you're not going to see all of the numbers. You don't need all the parentheses and everything set up for this one. Make sure you are still using the right equation though. So for y equals, we want x minus h squared equals 4p y minus k. So x minus h squared equals 4p y minus k. But we don't need to write plus and minus zeros. So you would actually just want to write this as x squared equals 12y. Don't write adding and subtracting 0 or multiplying and dividing by 1. So for our last example, there is a little bit of a trick, and I've given you a hint on this. And the hint says that the vertex is halfway between the focus and the directrix. So if you look back at the graphs, you can see that the vertex is always the point that's in between your directrix line and that focus point, the one that the parabola is kind of sheltering and protecting. So it's always in between those two objects, and in fact that distance is always exactly halfway between them. So if you can see that your parabola is opening to the left and to the right, and if you know the directrix and the focus coordinate, then you can find the vertex by cutting that length in half, find the midpoint between them basically. So that's what we're going to do on this last example. So first, let's note that we have the directrix is y equals -1. So the directrix is y equals, that means it has to be this left column of equations. So I have k minus p equals -1. Now we also have that the focus is -4, 3. We want to use the same equations, so the focus is h and then k plus p. So h is -4 and k plus p is equal to 3. Now, one way we can actually find our k value is by just using the rules for a system of equations. You might also notice that we have a k plus p equals 3 and a k minus p equals -1. So you could combine those two equations, and if you use elimination, the p's will cancel out. So that would look like this: k plus p equals 3, k minus p equals -1. If you add those equations together, you get 2k equals 2, which means k equals 1. But the other way I was talking about finding this was by looking at the y coordinate of the focus and the y coordinate of the directrix. And if we have our graph and there's a directrix going through at a height of -1 and our focus is at a height of +3, then what would be exactly halfway between those two heights? So from a height of 3 to a height of -1, halfway between would be a height of +1. So that's two ways you can actually find that k coordinate. Now we haven't actually labeled what the p value is, but since we know k equals 1, you can plug that into either of these two equations we wrote earlier and then solve to get the missing value. So in this case, I'm going to plug into the formula on the right, I guess. So I'm going to have 1 minus p equals -1. If you subtract 1 to the other side, that gives you -p equals -2, which means p equals +2, and 4p must be 8. So now we should be ready to write our equation. We have the h value, the k value, and we know the 4p value. Those are the three things you're looking for. So looking back, we just want to make sure that we plug them into the right formula. This was the case where we have the parabola opening up and down. So we're going to be using the x squared equation because this is an up or down parabola. So I'm going to write x minus h squared. And when you subtract -4, that's the same as adding 4. This equals 4p y minus k. So that should be all for the notes. Many of the problems you'll be doing for practice are multiple choice, which will make this even easier. You just have to be very careful about the signs as you work on these.